Hey everybody, good morning. Just wanted to give, first of all, a quick outline of some of the things that we're going to be looking at. Some guards, some utility types, lookup types, generics, conditional types. I also just want to invite you all to be asking questions in the chat, commenting in the chat. If you know a different way to do things, we can definitely talk about that too. And before we get started, just to reiterate what Jacob said, we have lots of content on YouTube, Twitter, Instagram, and on our website. So I just want to invite you to like and subscribe. My name's Kelsey. I'm a senior developer at Headway. I've been at Headway for about 2 years now. I love React. I love Material UI, TypeScript, and also I love this cute guy here in the corner. That's Zeppelin. You might see him in the background. He might walk through at some point. All right, so let's just jump into it. Guards are the first thing that I wanted to talk about because in my experience, I've been working in my client work day to day with APIs that can return multiple types in an array. And sometimes you want to pass whatever you're getting back from an API, and it might look something like this. In this example, we have a document, and it may be coming back from the API, or maybe it's coming from local memory or something like that. And it's either this delimited document type or a plain text document types, because we have this union here. So this should look familiar if you have a basic understanding of TypeScript. But then, we have these different functions. How can we figure out what is this doc type before we pass it through to either print delimited, or print plain text? And you may see like an argument along these lines. In this case, it's saying, our delimited document is going to have a property separated, and that makes sense because it's either going to be like maybe a CSV or a tab separated document, and our plain text document will not have that. And so maybe this print delimited is dependent on that. And so it's just giving us that warning, if this ends up being a plain text document, I don't know if it is yet, this print delimited is going to not work. So really simple solution just based on the error that we got is, it was complaining that separator was not present if this is a plain text document. So one of the first things that you can do is use the TypeScript in operator, in. And basically all this is doing is it's saying, if this separator key is in this document object, then we can just pass it through to print delimited and it will work. Otherwise, we can just pass it through to print plain text. And I'm just going to also quickly show this in Code Sandbox if you're following along that way. Here are those two types. I didn't have these types in the slide deck, but you can see here we have a separator type of comma or tab. Here are our two functions. And here's how the if separator in doc works right in TypeScript. And here's our original broken example. And when you hover over doc, you can see that that's what it's complaining about, the separator being missing. But that's just one way that we can guard against passing the wrong kind of type into a function. Here's another scenario, and I may switch this over if y'all can't read it, but the idea is that we have a function here called send email, and it's expecting a final invoice. Let's say, you have a app where you start to build up a order form or something like that for your user, and when you have the final invoice, let's say they go through the purchasing process and you want to email them that. Well, here in our invoice mailer, we're saying, we'll have a invoice, but it's more of this generic invoice type. And so on click, when we send email to invoice, this invoice could either be a final invoice, which is what this function is expecting, or it could be a draft invoice. So another issue. And maybe there's a case for using that in operator, but the way that I've solved this one is using type predicates. So first, I'm just going to show you, here are those types. So here's final invoice. This type name will be familiar to you if you use GraphQL. It gets appended on here to say what the type of this is. So it's a final invoice, draft invoice, and there would be some other fields here. But here what we do is we say we have an invoice, which is a union type, so can either be final invoice or draft invoice, because there will be places where for those two types, it may not matter, which of them it is. It will accept either in like particular components or functions. But in a case where you need to know, is this a final invoice or a draft invoice, you can use type predicates. So the way that you set up a type predicate is you accept the more of the generic type or ambiguous type. In this case, it's the union type of it's either going to be the final invoice or the draft invoice. And then you have to do something particular here with your return type so that then TypeScript knows what this type is after this function executes. And what it is you say invoice, which is my parameter. We're saying this parameter is final invoice. And what this is saying is if this returns true, the invoice is a final invoice. If this function here, checking on the type name that I pointed out earlier, returns false, then it's not. Same for draft invoice. We're saying this invoice, which could either be a final invoice or a draft invoice, is it the draft invoice based on checking the type name? If it's true, yes. If it's not, false. And here's how we would use it in our code. We would say, and do we have a selected invoice? Because on a previous slide, it said that could be undefined. And then, is it a final invoice? If this executes to true, then we will use our double ampersand to display a button on the screen whose on click is send email. And because this evaluated to true, the selected invoice type is now of the final invoice type. And I'll show you what that looks like in the code too, because we did jump around a bit. Let's see. So here's more of a fleshed out type here. And you can see there are some other things that change between final invoice. So here we couldn't really have used a in operator because there are, I think, mostly common fields here. Yeah, inserted at. Some of them are optional for the draft. That makes sense because you're drafting it, you're building it up a field at a time likely. But the real thing that we're concerned about here is this type name field. And so that's how these work here. And if I do something like invoice so here, when this is an invoice, I can give it either. So I'll just make this one a draft. And let's see, what are my required fields? Inserted at. And it wants line items. So here I have my invoice type, and I can say, and pass in the invoice, and then this would return true because is draft invoice. It's going to look at this type name here and evaluate that the invoice is the draft invoice. But if I said it was final invoice, that would evaluate to false. So another interesting guard that you can use are these assert functions. So this is more something that you would use for like scalar types. So in this case, it looks really similar to the predicate that we looked at earlier because it has this is keyword. But what we're saying is we're going to assert that this value parameter that gets passed in this case, is a number. And if the type of the value is not a number, then we're going to throw this assertion error, not a number. And that's great for cases like this where we have a function double. It takes any kind of input. And then if we assert it as a number, if this fails, then it'll throw before it reaches here. And so if our concern is we don't want this input to make it past here, and if this input ends up being like a string or something, we would get, this cannot call, ×2 on type string or something like that. Whereas here we get a very specific assertion error, and we can do something with it. We could catch it or something like that. All right, so that's all of the guard functions. I'm interested to see if anybody in the chat has a different way that they go about it. I typically reach for these type predicates just because I like to be really explicit in my code. What am I checking for? Something like where we're checking for is the separator in doc. It's okay. And it can be really helpful too when you have non-alias types, like if you use something like CodeGen and it's generating your TypeScript types based on your Apollo schema. And let's say you don't have control over what your Apollo schema looks like. Something like this could be helpful to figure out, if there's a nested union somewhere, do I have the fields that I depend on in order to call whatever function, in this case separator? This can be really helpful. But in cases where you either are the one maintaining the API or you just have some kind of influence over that, I like these because reading through the code, you can tell exactly what you're trying to do. If you come across is final invoice, you can, even before you look at the implementation, you can say, okay, well, they're trying to guard against, not letting something through that's not a final invoice, that kind of thing. And then these assert functions, I haven't used these much. A colleague of mine pointed these out to me, but they seem like they would be really helpful for the same reason. You can be really explicit about like, what is the issue here? It's that I was expecting a number and you pass through something else. Okay, now we're going to move on to lookup types. So this is another case where I run into this a lot using CodeGen, where there is a this highest level type of route, and then there are sort of these implicit nested types that are not aliased, meaning they don't have a name. And in this case, let's say, I'm going to take the origin like object off of the route, and I kind of want to pass it around and use it in different places. And so what you can do is you can say, on this route, I know that there will be a member called origin. What I'm interested in is getting that type. And so in this case, where we have type origin is this origin key on route. So everything between these, including and between these curly braces, I can use that origin type and I can say, okay, so this trip origin is going to be city is Denver. That corresponds with that. State is the Colorado right there. And then the way that origin and destination differ from each other is in this example, origin might have a departure fee, and that would be a number. And so I have that departure fee here just set to a random number. Likewise, for the destination, it's the same thing. And it's great if you have control over this and you can alias it like right out the get-go. But if not, you can do it in this way. And generics was what I was going to talk about next. Okay, so generics is not a new thing, but I feel like they're underused when I'm seeing different projects. They're really powerful in that if you think about, we have functions that take parameters, and the parameters are used in the implementation of a function. Generics are similar in that a generic allows you to have a type that takes a parameter. Often it's abbreviated as T, and then you can pass the type through. So in this case, I have a enum, and that it's a task type, and the task type can either be a feature or it could be a bug. And so for a generic type that's a task, I'm just going to take task type as a whole and say a task will have a name that's a string and a type that's a T. So in this case, I'm just made this whatever task, has a name of single sign-on. The type in this case is task type.feature. I could later down here change that to task type.bug. I could have used task type.bug up here. But if I want to have a more specific type, which I feel like specificity is where TypeScript really shines if you take the time to be specific in your types, I can say, I want to instantiate a different type called feature task. And it's this task type up here, but then I went ahead and passed through a specific task type value from that task type enum. So in this case, task type.feature makes perfect sense there. Then I have created this feature object, calling it a feature task. And the name again is single sign-on, the type, in this case, task type.feature. But then in this case, where I try to change it to bug, it's saying it's invalid type. Because here in feature task, I said task type.feature, passed in here to T is going to be the type. And so I can't use anything other than what I've defined here. Likewise, just creating one right off the bat that's invalid, passing it the type of task type.bug is not going to work. And let me show that one in the code as well, just in case you're following along. Yeah, so here are our errors, and the errors are really helpful. This is actually supposed to be task type.bug. There we go. We still get the, task type.bug is not assignable to task type.feature, which makes, perfect sense. It's very explicit about what it is complaining about. Same thing here. Okay, so this is similar to what I was talking about with the code gen scenario, where you get a type that is a union of different combinations. And so here's an example of a type called trip. And these pipes indicate that this is a union. And so the type trip can either be an object that has a origin on it, that the origin then has a UUID, a city, and a state, or the trip type just has an origin UUID, so that's a identifier field, and it's just a string, and maybe I'm going to use this UUID to look up these other values elsewhere. And so these two types are pretty different, like this is an object with some fields that are scalars. This is just an identifier. So what do you do with that if your code gen generates something like this and you want to deal with these separately? So in this case, I have defined two types using this extract utility. And so with extract, you can pass in first a type that you want to extract from. So in this case, I've passed in trip for both of these examples. And then you pass in what do you want to match on. And so I want to extract from this union type, and again, extract accepts a union type. I want to extract a type that has matches this pattern. So an object that has an origin UUID, that's a string. And so this trip with origin ref is going to be set to this one because this is the only option that is the origin UUID string. With the second example, passed in trip, but then I want it to extract out a type that matches this pattern, which is an object that has an origin field, and the origin field has a UUID of a string. And what's cool about this is I know that the main ways that these two union types differ is that this one I just have the UUID, and then for the this trip I have the origin in like as a whole object. And I don't have to pass in the city and the state as well. I just know that there's going to be an origin, it'll have an identifying field, and it'll pull off all the other fields as well too into this trip with origin whole type. So I define those two types, and then I've set two consts here. So trip origin ref, I gave it that first type, and it accepts an object with an origin UUID that's a string. And then, that would obviously be a lot longer. This is a placeholder. And then trip origin whole uses that same type. And now I just pass in a origin, and it has its UUID, it has its city, and it has its state. So this one's really powerful when you're using CodeGen because you can get back a lot of unions, and it can be really frustrating to like figure out how to just use one part, because you'll get those like these are not compatible types. Like I'm expecting it to have I'm expecting an object that has origin UUID and origin that has all these things, and you're like, well, I know it's going to be one or the other. How do I know? And you can use this trip with origin ref. And also what's great about this is you could use this in conjunction with those type predicates. So then you can have a type predicate that was, or a function that was, is trip with origin ref, and then use this extracted type. And, oh, yeah, so that's basically what I did here. And then here we're doing a filter. We have a trip with origin ref. That's the one that I had on the previous screen. And I instantiated an object. Well, actually, what I'm demonstrating here is that these are two objects that don't have types explicitly defined on them or set on them, but we can still create this type predicate has origin ref using that trip with origin ref. Here our in operator, see all these things kind of build on each other. Our in operator is present, so we're saying, is there an origin UUID in trip? And then we can filter on result. We would pass both of these objects in, filter on has origin ref, and what we would get back would be just this one. And let me just pull that one up in the example as well. Okay, so here's our extract example. We have the trip, has these different unions. We extract them. And then here's our example where we do trip origin ref, trip origin whole. These will match these two types. I just haven't explicitly set them. And a lot of times you're not actually going const and defining all these things. These are things that get returned back from an API. So you don't have an opportunity to set a specific this kind of thing. You don't have an opportunity to do that. It's just coming back from the API as unknown or something, right? And so having this is ref, the wording's a little different than what you saw on the slide, but it's the same thing. We're checking for origin UUID and trip. This result would come back as a array that has that origin UUID there. All right, let's go back to the slides. Okay, conditional types. So in this scenario, I have these different types here on the left. So I have a type that is diesel, a diesel engine, and that can either be a petroleum diesel engine, a biodiesel engine, or a synthetic diesel engine. And then I've also given a type of gasoline, and I'm saying the type is hybrid or conventional because we have our union type there. And then I've also defined two kinds of vehicles. So in this world, there's a type bus, it has an engine that's diesel, and then we have a type car whose engine is gasoline. So if you wanted to get just the engine type off of a type T, and here's our generics play in again, we can have a type engine that accepts T, and we'll say we have a ternary here. So this is our conditional. And so we're saying if type T extends, and what this is saying is an object with a field called engine, we don't really care what the type is. If it has this engine field on it, then return the engine field. And here's our lookup types that we looked at earlier. Otherwise, we're just going to return never. And so because if a type T with no engine on it, the engine is never going to exist. So we can say type bus engine, and we can say, engine and pass it in this bus type here. And because it has engine here, we can then use bus engine, and we can say, okay, I want a new bus engine. It just, this is in the, what do you call it, the mechanic shop or something, and they're, building this bus engine, and they're saying this is going to be of a type bio. And we know that that's okay because a bus has an engine, diesel engine, and bio is acceptable. Likewise for car, we can extract out or use conditional types to figure out what the car's engine type would be. And then one of the acceptable values there is hybrid. But what's great then is, with this invalid engine that I tried to create, I've said it's going to be a car engine, but then I tried to use this type bio from diesel. So that's not going to work. So it catches that. And here's an example where that never would come into play. So I've added this new vehicle called bicycle, and it doesn't have an engine, but it has power, and it uses your limbs to power the bicycle. And I've used conditional type, just called this no engine, and it's an engine for the bicycle. It's just going to return never. So then when I try to use the no engine type and say, okay, well, type is limbs because this, that's how I power it, it's going to tell you no, that can't be assigned. And this is good for catching issues as you start to build out your data model. And cars and buses and bikes are probably not something that you encounter all the time, but you will encounter things that are in a closely related to each other when you're working in an industry. And sometimes you can get some ambiguity around, like, well, does a bike have an engine? Are we calling using your body to power it an engine? And here you can be sure not to introduce any bugs, because it'll catch it and say, no, bicycle does not have an engine. Here's another example of how you can use conditional types. In this case, I have something called a backlog, and a backlog has releases, sometimes also called sprints. And in this case, my first release is called Sprint 1. My Sprint 1 release has some epics, and in this case, it only has the one epic, but its name is account management, and there's some tasks under that and everything. And I could do type of backlog, and it's going to be an object with releases and all that. But if I just wanted to get the release type off of there, I can, first of all, I can do type of backlog and get whatever the type of this backlog is without defining it explicitly. Again, this is one of those cases where you don't have a aliased type. And so I've gotten the type off of the backlog. And then off of that backlog type, I've gotten releases. But if we just do this piece here inside of these angle brackets, less than or greater than signs, this is actually going to return a array, because if you look, releases is an array of this type. And sometimes you just need a single type. And so you want to unwrap it, or the terminology I use here is unarray it. And so here we are passing in the type T. So in this case, unarray type T is this releases array type. And we're saying, does T extend array? And then we're using infer to infer what kind of array it is. And if that evaluates to true, then I have a reference to U, and I can just return U. So then our type here, release, is a single release. Whereas if it doesn't, and this is just a personal choice on what you want to do if you write an unarray helper function like this. If it doesn't extend array, if it's not an array, I'm just going to return back the type. So if I just passed in a string or a number, it would just return a string or a number. You could also have it return never, and that might be a good check. You told me to unarray this, but it's not an array, so I'm returning never to kind of halt your progress down this path that you're trying to go on. But sometimes it just makes sense. You're like, it might be wrapped up, it might not. What I'm concerned with is, what is the type that's either inside of that array or just the array. So I'll show you this one in code. Let's see. This one's here in backlog. And so again, I have this backlog. And here's that code I showed you. So if we did something like, and if you're not using, type of, that's a great tool too. But if I did type of backlog and releases, I could do something like, so that's valid. It's giving me a complaint because it's saying you then go on to not use it, but that's valid because it's an array. It's expecting an array. But if I look at releases and I say, okay, I want it to be this, just the first release, it's going to complain about that. Because you see here all these square brackets saying, sometimes these can get, kind of long and crazy and you really don't know what to look for. I normally just scroll right down to the bottom and see if I can get some hints here. And this would be a big red flag for me, all these square brackets, like, okay, it's expecting an array of some kind. And so that's when you can use an array. And I'll just export this so you can see that warning goes away. So then that would go away. So now I can use that, or I can use my release type up here that I already defined. Like that. We could even do the same thing if we wanted to, let's say we want the epochs off of that. We could say type epoch equals release epochs. So right now this is still an array, but we could unarray that like that, and then have our epoch type here. Like that. And so again, these are great. These conditional types are great when you are getting data from an outside source like an API, and you maybe have a generated type without those aliases, and you can dig down and get different components of it. This is also really great for when you're using GraphQL and you have different queries, and maybe in one part of your app you are selecting a handful of fields off of a resource versus another one you're maybe you're getting 5 more off of that one. A lot of times you can use like return type, which is another utility function, and figure out what the return type will be for that specific query. Like if you're using a use query hook from Apollo client, and then sort of dig down into actually what will be available from this query. Because sometimes if you just use a generic like releases, maybe on one query you're using releases, but you don't query the name in your GraphQL document, but you've used just a generic release type that you've defined elsewhere. You may end up calling that name and then have a runtime error. So this is a good way to protect against that. Okay, I see Jacob shared somebody's question. Now, how do you check type of trip with origin ref somewhere in the code? Okay, let's go back to that one. Where did I have trip with origin ref? Oop. Was it in generic? No, it's an extract, wasn't it? Okay. And I have this really zoomed in for for the live stream, so I'm a little clunky with scrolling around because it zooms by really fast. So appreciate you being patient with me. All right, so like this would be kind of an example trip with origin ref. Just to also talk about how this might come about. So the way that I came up with this example is loosely based on how something I ran into when I was working on some client work, which was we accepted a bulk upload comma separated value file from the user, and it was like they wanted to upload a bunch of different trips, right? But as we all know, sometimes you compile one of those bulk upload files, and some of your um, rows will have errors in them. You've just done a typo, forgot to fill in a cell, something like that. And so what would come back from the API after you sent all the data from the CSV file to the API was a combination of draft trips and persisted trips. So it had gone through the file and said, okay, for all, most of these rows, I was able to just persist them to the database. It was no problem. But for some of them, they didn't quite work. So I'm returning those to you to fix them and then send them back to me, right? So I would get something like this back. I would get, for the ones that had been persisted, I would get a UUID because that's the identifier field in the database. That's how I would then go back and look up that origin later, would be by its UUID. Also, if you're not familiar with UUID, this is like the same as like an origin ID. And so this would be like a persisted example, and this was like more of a draft example where it was saying, I have this origin. I'm giving you a preliminary UUID, but I haven't persisted this to the database yet. But this is so that we can keep these all these different draft origins straight. And then here's the city and state that you provided, but maybe, you gave me a crazy city that doesn't exist. I looked it up and it doesn't exist, so you need to fix it. And so that's how I would use something like that. And when I'm looking at what's returned from the API for these ones that need to be revised, I can look at it and use something like is ref, or maybe is draft. Like, let's say we write one that's is draft. What was this one called? Trip with whole object. Trip with origin whole. Okay. So anytime is draft evaluates to true, I might show them a form. So I'll show them like a couple inputs, a couple text inputs for in this city and state that would then be pre-filled to say Denver and Colorado. But let's say I put what I had returned was like this because I was starting to write it, but then I got distracted, didn't write it correctly. So then I could show them a form where they could fix this, send it back to the API for revision or for persistence, check it again and then persist it. I don't know if that answers the question. I don't have a great like built up example where admittedly this is kind of weak, just filter on it, but you can build so much on this just using use it anywhere in your control flow where you just want to assert that something is or validate that something is the type that you're expecting. I'm glad HK can relate. Yeah, and all this is in, and I'm kind of saving this as we go. So I think Jacob said that he had shared a link to this code sandbox. So I definitely invite y'all to fork it and try and play around with some of these things. Okay, so let's go back to the code though. Oh yeah, so next steps here was there's a link here to the source code that's in the chat, and I think Jacob will be sending that out to everybody. And then another great resource here is the TypeScript Handbook. They have a lot of great examples in a similar vein to what I've shown you. I'm hoping what you could take away from this talk is some of them in just a quick survey of some of the ones that I found most valuable, and just some additional ways of showing examples to theirs, because I know you can sometimes you read one example and you're like, I don't know, I totally get it, and then somebody else puts it in their own words, and you do get it a different way. Cool. Jacob, do we have any more questions? I think that was the end of my slides there.
I don't see any more questions. Looks like someone just came in and said that they missed some, but you can go back, and this is the happy person I'm speaking to. It's a great username. So this is being recorded. This will be on our YouTube channel. So yeah, and you can always go back and live. You can go backwards. I just added the TypeScript Handbook link in there. And I'll just paste the code sandbox stuff again for folks again in the chat, just so it's there. Awesome. Yeah. So if anyone has any more questions before we wrap up today, we have a little bit of time. But yeah, awesome.
Yeah, and I'm really curious if anybody uses, gets to the same end by a different process, because I'd love to dig into that. And
we got fans of your other presentations. So
hey,
awesome.
Yeah, speaking of that, actually, let's quickly, since we have a few moments, let's look at, I can't go too long without talking about material. Let's just add it to this project here.
Just doing it live.
Yeah. Let's see. Let's create a brand button type. Wow, this is really crazy doing this at such a high, big font size. Okay. So let's say we're creating a brand button component, which I wouldn't do this if you've seen my Material UI course, but let's say I have to do it anyway. And it just returns a button that has some text in it. Okay. So a few things here. Obviously, it's complaining right now because it doesn't know what children is. So one of the things that you can do is you can use React.functional component, or FC is the shorthand. You could write either one. And then it will have a reference to children. Let me quickly import that though. Okay, so that's a simple thing you can do, but obviously this is just a button with all the default options from Material because I haven't passed in any, I haven't set any. And what a lot of people will do is they'll reach for something like, they'll say, well, I want to be able to change the color, and the color should be, I know that these are the values that are allowed. So primary, default, secondary. And then you can pass these. Again, here's our generics coming back. You can pass those in like that. And then they'll do something like, okay, oops, don't use an emoji. And they'll say, okay, color. And then I can pass through color here, right? And that's okay, that lets you pass through color. But, if you know from the outside that brand button takes or is a Material UI button inside, you don't necessarily know that color is the only field that this brand button developer decided to do. Maybe you want to, you also want to change the variant. You want it to be outlined or whatever. What you can do is, instead of defining all these props like this, you can, out of the Material UI core library, you can get button props. We can delete this, and then we can pass into this generic button props. And so now, any of your props that are acceptable by button are acceptable by this button are now also acceptable by brand button. And so what you would probably do is do something like this: rest, and then spread those on your component, right? So now I can use brand button, and I can go to Material UI, and I can go to button API, and if it will go, except for that's taking us to button group. Here we go. And now I know I have all these props, right? Because I can just look at it. But let's say, this is my brand button. If you can just do anything that you want to do to it, that you could do a material button, that's not going to work. So let's say I only want to let you, you can do anything except for change the variant, let's say. So I could do something like type props equals omit. That's another TypeScript utility function. Pass in button props, and then say, I don't want to let you change the variant. And then I pass through this. And so if I was going to try to get variant off of here, it should now, yeah, and now it's not, it doesn't exist because I omitted it. So if somebody tries to use my brand button and pass through the variant, which we know is an acceptable type on just a material UI button, can either be contained, outlined, or text, I can prevent them from being able to do that with omit. So that's a use case there. And actually, this is a case where I might use a brand button if, maybe if anyone else knows a better way to do it, like if I just wanted to disable particular props on a component, or you might just, if you're really concerned about somebody changing the variant and you don't want them to, you could just make in your theme overrides, just make all the variants the same. So that could be something you could do. And if you're interested in theme overrides, I have a talk about that on the Headway YouTube channel and a corresponding blog post. So yeah, just a lot of, and I mean, all of this is using very similar things to what we, we're just talking about. We didn't talk about omit, but that's another utility function that you can find in the handbook that I linked at the end of that slide deck, using a generic here. So yeah.
Awesome. HK was asking just about future events and stuff like that. So for anyone wondering, if you subscribe to the channel here, you should get updates on upcoming live streams. But if you also go to headway.io and then go to our events section on the website, you'll be able to register for upcoming events, add it to your calendar through Eventbrite, all that kind of stuff, get reminded about it. Because I know it can be hard to remember to go on YouTube or all that kind of stuff, or you don't want all the more notifications if you want in your calendar. It's an easy way to do that. And as Kelsey said too, make sure you go to the blog. There's stuff with material UI she talked about, as well as a lot of other topics in there. If you're interested in growing in your skill set in many other ways, even stuff about best practices for managing teams, for retros, pair programming, all that kind of stuff. So a little bit of everything for everyone there. So awesome. Well, I don't know if we had any more questions. Looks like we just had one more comment here. Didn't know about omit, such a cool utility function. Awesome. Well, I think we can wrap things up. It's been about almost an hour now. I'm just going to share my screen quick and just kind of walk through some things that are coming up here. Sure, I'm sharing the right one here. All right. Let me just go back to the events. So as you can see on our events page, here's today's event. You could have registered for it here. Otherwise, YouTube is just as good. We have some presentations come up next week that are more focused on product and design. But if you're interested, feel free to join them. So Teresa Torres will be talking about continuous discovery habits with products. And then Billy from our design team will be talking about creating user flow diagrams from customer journey maps. So before any design, UI is even thought about, like how is the information being sent, wireframing, all that kind of stuff. What is the path and the user experience? How does that get all mapped out? And how can you do that with confidence, right? So some cool stuff. And as a reminder, a lot of these recordings from YouTube here are also available on our website with more notes and links and resources and all that kind of stuff. So be sure to check those out. Figma tutorials, design systems, React.js tutorials, stuff like that. So, and also wanted to share that we are hiring a Headway. So if you're interested in joining our team, unfortunately, we can only hire within the United States at the moment. But if you or anyone you know is interested in looking for an opportunity to work with us, we're hiring a design, product strategist, and a lot of development roles as well. And as I said before, head to the blog, headway.io/blog, and you're able to find the collection on development with all the different articles we have in there. So awesome. Well, cool. I think that's all we have for today. Thanks again, Kelsey, for being an amazing teacher and sharing your knowledge and doing some live coding for everybody. Even though the text is super giant and can be hard to navigate, we appreciate it, and we appreciate everyone here watching, being patient with Kelsey as she shares everything. Oh, look at that. Thanks, the happy person. You're too kind. Awesome.
Oh, thank you.
Yeah, Kelsey doesn't have any events on the calendar yet, but don't worry, it'll happen.
Probably later this summer, for sure.
Yeah. We got to give her a break. She works really hard. She does a lot of great stuff for our team.
Yeah, I think next week or next month, just as a little preview, is going to be Tailwind CSS, I think, and that's going to be, I think, by my colleague Chris. So keep an eye out for that. That one will be great too.
Yeah, we're wrapping up all the promotional parts of that, like all that stuff. So yeah, so be on the lookout. We appreciate everyone being here. Thank you so much. Yeah, good vibes for sure. Just reading all these comments here. Awesome. Well, thanks so much, everyone. Everybody have a great day.
Thanks, y'all. Bye.